In the last lesson, we learned a lot about working with linear and nonlinear functions. So, what do linear graphs look like? Hopefully at this point you should be thinking these are your straight lines. It could be horizontal, it could be slanted going up or slanted going down, but they are straight lines. Whereas when we look at nonlinear graphs, we should see, obviously, not straight lines. Now, if we're thinking not straight lines, they could have a curve to it. So they could curve up like this, or they could curve down, exponential. They could be those step functions that you saw, where you had something like this, and then it went something like this. Those would be non-linear. It could be when you have something like this, which we'll get into in later units. It could be a V shape going up or down. It could be kind of a parabola that looks something like this, where you kind of have a point, but it's kind of a U-shaped instead of a V-shape. So all of these would be non-linears you're adding to your notes. So as we graph our functions, the key thing that we want you to do is we always want you to make a table. Now, in this one, you might notice that the x is to the first power, which makes it linear. And as we look at that, this is our y-intercept. So we're going to start with x and y. We're usually going to put values going from -2, -1, 0, 1, and 2. We're going to do that in both tables, so add that to your notes for both of these. And what you're going to be doing is substituting in the values and solving. So in this case, we want to replace the x with -2. If we are doing that, that gives us the point -1, and I'm going to do that work kind of down below here just a little so that you can still see it. I think on your graph also, there should be enough room for you to show your work here. So in that first one, we're going to do -1 plus 2 times a -2. If I'm looking at solving that, that's -1. Remember, we have to do order of operations, which would give us plus a -4 to give us this value of -2, -5. Next, we want to plug in -1. So 2 times a -1. That's going to give us a -1 plus -2, gives us -3. Notice our rate of change here is going up by 2 as x increases by 1. So if we plug in 1, we should get, plugging in 1, we get -1 plus 2. Again, when we plugged in the 0, you should have got -1. So -1 plus 2 times 1 gives us -1 plus 2. That gives us 1. And the last one would be 3. We now want to plot these. Remember, these are ordered pairs. Every time as we look at those, it's an ordered pair. So we have -2, -5, -1, -3, 0, -1, 1, 1, and we have the point 2, 3. So if we are going to graph this, this is a nice linear equation. We want to, again, connect it as we've done before with our linear equations. Connect the points with a line, and then extend that line and put arrows on it. As we look at the next table, and again, we want to substitute in these values. As we go to substitute in our values, and I'm going to do that work down here, we're going to put in -2 for x. We want to put it in a parentheses, square it, -4. Remember, -2 squared is +4, and 4 minus 4 is 0. Next, we want to plug in -1. If we are looking at -1, we want to put in -1 and square it, -4. Well, -1 squared is going to be 4, or is going to be 1, -3, which gives us a -1 minus 4, which gives us a -3 if we are looking at that. So at -1, we have the point -3. We plug in 0. Well, 0 squared -4 is going to be 0 minus 4. That is a -4. We're going to continue with this work. We plug in 1 and square it, -4. That's going to be 1 minus 4. Gives us the same thing as when we plugged in -1. So when we plug in 2 and square it, 4 minus 4 is going to be again 0. So we want to plot our points. -2, 0. Remember, X always tells you to move left and right on your graph, Y up and down. -1, -3, 0, -4. And again, remember, these are all ordered pairs. 1, -3, and 2, 0. So if we're looking at this graph, it's kind of a big U-shaped graph. This is called a parabola. Next year in algebra, you work on it with your quadratics. It says label these as linear or nonlinear. So at this point, we want to go back and we would say that this first one is definitely linear. Why? It makes a straight line. This one is non-linear. Again, did not make a straight line. So what you are going to do on this next one is you're asked if you can identify, kind of thinking back to our slope-intercept form, what is our slope? Now, remember, as you look at both of these, I'd like you to pause the video and write down your slope and y-intercept for each. And again, when we write our y-intercept, you can write it as a number or the ordered pair, and then think about graphing. So we should have seen our slope was 1. We might want to write it as a fraction of 1 over 1. The y-intercept, -3. Remember, that's telling us on the y-line. Slope of 1 means up 1 and over 1. So as we plot this, and then we're going to use our straight line, straight edge, and draw that line. Again, if we look at this, this one should definitely be linear. Again, our variables to the first point, what's our slope? -1/2. Y-intercept 3. Remember, y-intercept 3 means 0, 3 on the y-axis. It's a -1/2, that means down 1 over 2, down 1 over 2. We could go up 1 and go back 2. Negative slope means our line has to slant down. If we are looking at that, always down to the right. So we are now going to take that line tool or using your straight edge and extend that line. And again, we would have this one is also going to be linear. And I want you to notice the x is to the first power, as is the y. So when we look at linear and nonlinear, if it is to the first power. So it says for a nonlinear function, you want to make your table and label each of these again as linear and nonlinear. Noticing here, could we tell if we were looking at this one, if it's linear or nonlinear? Well, it says if it's nonlinear, we definitely want a table. We notice this is to the first power. So if we are looking at that, we want to say our y-intercept, in this case, would be 0, 0, and our slope is -2 over 1. 0, 0, down 2 over 1, down 2 over 1. And again, if we can use slope-intercept and x is to the first power and y, we are going to have a linear function, and we can simply graph that right away, noticing that, and say that this on the test would be a linear equation. Could we make a table of values? Yes. If we look at this table of values, at -1, what was our point? -1, it was 2. At 0, it's at 0. At 1, it's down at -2. At 2, it's down at -4. So you can make a table from the graph, or you can plug in those values in x for 0 and solve and get the table that way. Now, as we take a look at this equation, we haven't really seen these absolute value signs since the beginning of the year. When we look at that absolute value, that's kind of a tricky one, and so I want you to make this table right behind, and you should have enough room in your notes to put this table. We're going to put x, and then I'm going to put your work. And then way back here in the table, right next to the edge of your paper, is going to be y. So when I take a look at this, again, I'm going to plug in some different values. Here, I would like you to plug in, and I think what we'll do is we'll go with -3, -2, -1, 0, 1, 2, and 3. So we look at this function, we think, oh, that doesn't look anything like what we've seen. We are going to plug in to show our work. If we are showing our work, we want to put, sorry about that, trying to get the color of the pen to change, the absolute value of -3 plus 2. That means how far is -3 from 0? That's 3 plus 2. which equals 5. So my ordered pair that I'm looking at for that first ordered pair would be -3, 5. Plug in -2, that means the absolute value, we're just replacing the x of -2 plus 2. 2 plus 2 is 4. That gives us the point -2, 4. -1, absolute value of -1 plus 2 is 1, plus 2 gives us 3. We love doing 0. Absolute value of 0 is simply 0. Plus 2, we have the ordered pair 0, 2. Now when you plug in 1, I have a lot of students often get confused. The absolute value of 1 is simply how far is 1 from 0. So that is 1 plus 2. That gives us 3. Absolute value of 2 plus 2 gives us 2 plus 2, which is 4. So our ordered pairs, and we can write each of these as an ordered pair. So we're going to go to the first one, -3, 5. -2 was up at +4. -1 was at 3. Then we got to 2, 0, 2. And this one, instead of it being a nice curve like we saw before, this one is a definite V shape. Is it linear? Definitely not. It kind of makes two lines, but it does not make a line. It is that V shape. So this one would be non-linear if we are looking at that. This one is a straight line. We consider that one to be linear. The last two that you are going to do before we start your homework is you are going to look at these two graphs. Again, if you can look at a table, you want to put a table, and so I'm going to have you practice them, and after we've checked your work, and again for this one, definitely need that X and Y table. So as we take a look at that, and again, think of -2, -1, 0, 1, and 2. We're going to plug those values in. You could do the same here, or you could recognize what do we know, slope and y-intercept, and try and graph. So I'm going to have you graph those right now, check with your shoulder partner. I'll pause the video. You should do the same, and when he comes back on, we'll take a look at our table of values. So if we now look at these ordered pairs, I notice the second one has x to the first and y to the first, so I notice it as linear. So I am going to start right away at 0, -1 for my y-intercept. And I'm going to go up 1, 2, 3, and over 5. Now I can't do that again, so I'm going to go down 3, and I'm going to go back 5. And I'm going to take my straight edge and draw this line connecting those points because it was linear as I was looking at it. The first table, when you looked at it, if you plugged in the -2, -1, you should have seen it's kind of symmetric. But at 0, we had 0. At -1, you had 1. At -2, you had a +4. 1, you had 1. And at 2, you had 4. So when you look at these two graphs, this one is kind of that V shape, and this one would be non-linear. So when you look at your homework tonight, what are you going to be doing? As you take a look at your homework, if you notice the y and x are to the first, it says make a table of values for each function, then graph it. I don't care if you make your table of values before or after, you should have at least 4 or 5 values in your table. Now you notice this one, when you go to make your table of values, you want to go multiples of 4. So you might go -4, you might go 0, and +4. So have at least 3 values if it is linear. If it is non-linear, like number 5 as you're looking at it, you want to have at least 5 values in your table. This is a little trickier one. And when I talk about having these 5 values, I am talking about plugging in -2, -1, 0, 1, and 2. And remember, these will be inside that absolute value sign. So you're going to take the absolute value of -2 minus 2. That should be the absolute value of -4. That gives you 4. So be careful as you show your work. Same thing here. You should be making a table. Now, I think we'll have this homework quiz next. So the sub will hand out a sheet of paper for your homework quiz. And